Hi, I know I'm not seeing you in person, but at least I'm talking to you in person. You can see me talking, like kind of live, not really. I'm sorry, that this happened. I wish I didn't catch COVID, but I did, and I have been not feeling, at the top of my game, and because, it's a contagious disease, I guess, illness. I'm out for the week. So I think you kind of already knew that. And thank you for trying to make the best of it. Hopefully you have. If you haven't, please try to use the Khan Academy videos to try to guide you through um, adding and subtracting rational expressions. Last time I saw you Thursday and Friday, we did multiplying, dividing, and simplifying rational expressions. And so today I'm going to guide you through some notes. So please take out binder paper. Please write down as much as you can, and try to, learn this way. I'm hoping to be back on Monday. Just keep being great students, and be the best student that you can under the circumstances. It probably feels like great distance learning again, but it shouldn't be. I should be back soon. And again, I hope you're making the best of it. So in this little video, I'm going to try to go through the topic of solving equations with rational expressions. There are some tricks to it, and I don't have a paper copy that the teacher there with you is going to give you. But if you could just take it down on binder paper, pause the video, come back to it whenever you can. Please send me questions through Schoology, and I'll try to be back as soon as I can. So this topic is starting the next section. Sorry, I'm bleeding. That's weird. Is starting the next section of solving equations. There's lots of different types of equations. You should be able to do the next homework assignment after I go through this lesson with you. And basically, it's like adding and subtracting fractions, but there's an equal sign there. This is going to be my first example. And basically, what I also wanted to touch on is the concept of adding fractions. So if you didn't know much about this concept before this class, but somebody was introducing you to the notion of having a variable and trying to fill in for x to make a true statement, x would be in this problem right here. Good morning. 1. It's like you can basically ignore the denominator in a case like this, and you're solving the equation 3 plus x equals 4, and then 1, right? Because you guys are advanced. So this is kind of the same idea whenever you have x's, but it's not that easy to see that your answer is correct. You just have to trust the process and the answer book, and hope that you're doing it correctly. Because the thing with solving is you could always find x, go back and plug it in to see if it's right. But when x is in the middle of a fraction, it's not always that easy of a process to go back and just sub it in. So essentially what we're doing when we have x involved in an equation and there are fractions, you're going to try to find what the least common denominator is, so that we can cancel out each denominator, basically doing what I just did in this little made-up example right here. Is if all the denominators are the same, then I could just ignore the denominators, add the tops. So in this problem here, 2 is one of the denominators, and then x is another denominator, and so 2x is the common denominator. And what happens when you multiply each of these fractions by 2x is that you create a factor that's going to be common with each denominator, and so each denominator can cancel out. So here's my first example, and so if I multiply 2x over 2, the 2's cancel, right? And then what's left is just x. And then if I multiply the second fraction, 2 over x times 2x, the x's cancel, and what ends up happening is that there's a 2 left over. And then in this last portion of the fraction, I have 2x over x, so the x's cancel, and then I have 2 left over. So there's a couple of processes here that I did, and I just multiplied like each thing by 2x. But what you saw me leaving behind was basically what I needed to create a common denominator. So when I multiply the top by 2x, I leave the x over. And then when I multiply this one by 2x, the x gets crossed out and the 2 gets left over. But you can't just multiply a fraction on the top and keep it the same. So whatever I multiply the top by, I also have to multiply the bottom by. And so this is like another way of understanding what you're doing is that instead of multiplying each fraction by 2x and canceling things out, I can say to myself, well, what's the least common denominator? And if I know it's 2x, this one already had a 2, then I multiply this fraction by x. If the second fraction already had an x and I'm trying to make 2x, then I'll multiply this fraction by 2. And then if I multiply this last fraction by 2, then all 3 parts of the equation that were fractions all have 2x on the bottom. And I've changed this equation to basically just what on top. Sorry, this is not coming out as cleanly as I would like, but hopefully I've got enough examples that this will make sense. So in the end, I'm solving 1x plus this makes 4 equals 2, and that's super simple, right? You take away 4 from both sides, and then x equals -2. So the only thing that I want to be careful of is that at the beginning of last week, when we first started doing fractions, there are certain things that need to be excluded. X cannot be, in this case, x cannot be 0. And so before you do what I was about to do, which is put all these stars and have a little celebration, you want to make sure that the x that you came up with isn't one of the values that should be excluded. So hi, welcome back, Mrs. Falstington. I haven't taught in a couple of days, and hopefully that was decent, and we can move on to the next one. And then there's a couple here that you can try, and good luck. Okay, please send me the questions. Okay, this next question I see, like I said, I'll do 2 methods. Either I'll multiply each fraction by the common denominator so that things will cancel, or I will choose to multiply each fraction by something different to create a common denominator, and then basically just look at the numerators. Like those are the 2 possibilities. So on this problem, the least common denominator is this 3x right here that's sitting in the second fraction. So the least common denominator is 3x. And so one option is to take the problem that was there and multiply each of the fractions by the common denominator, and then cancel what you can and write what's left over. And if you've done this correctly, what you have left over won't have any denominators. So 3x times 1 over 3, the 3's will cancel and it'll leave an x. This -2 times 3 over 3x, everything cancels and you're left with the 2. And then after the equal sign, 1 over x times 3x, the x will cancel, and then it'll leave you with the 3. So x here, minus here, 2 here, equal sign, and then 1 times 3 is 3. Leaves you with the equation x minus 2 equals 3. Add 2 to both sides, x equals 5. Make sure it's not one of the excluded values. It's not. Do a happy dance. Right? So, like I said, the other option would be don't multiply everything through by 3x, but just try to make a fraction, each fraction have 3x as the common denominator. So I'd multiply this first fraction by x over x, same on top as on bottom, because you can't change the value of the fraction. This last one, if I want the denominator to be 3x, then I'm using multiplication. Again, once I see that all the denominators are the same, the real question is just what's in the numerator. And so that what I highlighted in yellow is left over. Whatever you hand wrote there is multiplied by what was existing. So this is going to be x minus 2 equals 3, same as this process. So it's just like a different way of looking at it. Whatever works for you, wherever you're getting the question correct, that's the method you want to go for. So I've got a couple of problems that I want you to copy down, try to do on your own. And then I'll make another video with some same question types, but just a little more challenging. So please go ahead and write those down, and then see you in the next video.